this Kevlar fiber. It is there in our syllabus. It is coming under polymer composites, right? What are these polymer composites, right? So these polymer composites were first developed for military and aerospace applications in 1940s, right? So these polymer composites it is a combination of two or more distinct components in order to form a new class of materials which are suitable for structural applications, right? So they are called as composite materials. If one of the component, right, if one of the component is a polymer, then it is called as polymer composites, right? So these polymer composites are comprises of two components. One is matrix, right? The other one is fiber. I will come to the fiber later. So the first component in a polymer composite is matrix. These matrix are usually a thermoset material, right? So I already explained what is thermoset polymer, right? So which upon heating it will become soft and undergo some sort of chemical reaction, and that converts themselves into some infusible or insoluble mass. You cannot reshape or retain the same. So that type of materials. So these are thermoset materials which are capable of embedding, encapsulating, adhering or reinforcing, right? So actually these matrix materials impart high strength and stability to the composites, right? And they are going to control their physical, chemical, mechanical and thermal characteristics, right? So examples for this matrix are epoxy, right? So phenolic resins, resins, so bakelite, right? So bakelite and polyester, right? And polyester. So these are the examples for this matrix. So coming to the second component, and that is fiber, right? So these fibers are the fibrous materials which give network structure to the composites, right? Which gives network structures to the composites. They are going to reinforce, right, or embedded into the matrix, so in order to make matrix more stronger. So commonly people are going to take fiber as a glass fiber. Sometimes people are going to use carbon or Kevlar fiber, right? So example maybe glass fiber or carbon fiber or Kevlar fiber. So this is our topic now, right? So these fiber reinforced polymer composites are very light in weight and they are very stronger. So they are often more stronger than steel, but weight is much less, right? So this is the reason why these fiber reinforced composites are used in the making of aircraft panels and automobiles later, so in order to achieve more fuel efficiency and less pollution, right? So with this basic introduction about these polymer composites and the two components, now let us move towards this Kevlar, right? So what is this Kevlar fiber? So Kevlar fiber belongs to a family of aramides. So Kevlar fiber belongs to a family of aramides. Here aramides means aromatic amides, right? Aramides means aromatic amide. It is an aromatic polyamide with a name polyparaphenylene terephthalamide, right? Polyparaphenylene terephthalamide, right? So here in this case of Kevlar fiber, the linkage through the para positions of the phenyl rings, right? So they are going to make a Kevlar a strong ability to stretch and hence its extra strength, right? So now let us see the synthesis of this Kevlar fiber. This Kevlar fiber can be synthesized by the condensation reaction between paraphenylene diamine and terephthalonyl chloride, right? Condensation reaction between paraphenylene diamine and terephthalonyl chloride. So if you write the structure of paraphenylene diamine, so it will be looking like this. Either you can write a circle on this, or you can write bonds. So NH2, NH2. So paraphenylene diamine. So at the para positions the phenyl rings are there. So similarly, so terephthalonyl chloride. So C double bond O, Cl. So actually we need to write N times we have to take, and similarly C double bond O Cl. So this is paraphenylene diamine, and this is terephthalonyl chloride. So terephthalonyl chloride. Okay, so these two monomers undergo condensation reaction, and they are linked through the para positions of the phenyl rings. So this is the reason why Kevlar fibers exhibit more strength and stiffness. So because of the linkages through the para positions. So if you can write, so minus NHCl, HCl will be removed, H from here, Cl from the this terephthalonyl chloride, it will be removed, and thereby the resulting polymer is called as Kevlar fiber. So if you can write, so it NH, right, and then phenyl ring, right, so NH you can write, and C double bond O, and then once again phenyl ring, so and C double bond, so O, C double bond O and N times, right. So this particular group is called as amide group, right. As aromatic rings are there, it is called as aromatic polyamide or aramide, right. As these two monomers are linked through para positions, hence its extra strength and stiffness, right. So this is called as Kevlar fiber, right. So IUPAC name is polyparaphenylene terephthalamide, right. So this is the thing. So Kevlar fiber is the first high strength synthetic fiber which gets accepted in plastic industry, right. So it is going to form even a better fibers than the conventional non-aromatic polyamides such as nylon 66. Compared to nylon 66, Kevlar fiber forms even better fibers, right. So that is the thing. And if you come and look at the properties, right, so the properties of this Kevlar fiber, so properties are, so as we have already given the introduction, so properties are in line with the introduction only. So they are, you know, very light in weight. The properties are very light in weight, right, and then they exhibit high tensile strength and stiffness, right, high tensile strength and stiffness. They are high, you know, corrosion resistance and abrasion resistance. They exhibit good thermal stability, and they are resistance to the chemicals. Okay, they are resistance to the chemicals. So all these are the properties. The first property is they are very light in weight, they exhibit high tensile strength and stiffness, a good abrasion and corrosion resistance, they are more thermal stable, and then they are resistance to the chemicals. Okay, and then coming to the applications, right. So coming to the applications, these Kevlar fibers can be used in so many places because of its light in weight and more strength, right. So the first application is they are used in the manufacturing of aircraft panels or lightweight boat hulls and race cars, right. The second application is they are used in the manufacturing of bridge structures and bulletproof vests, right, bridge structures and bulletproof vest. So they are used in the manufacturing of puncture resistance bicycle tires. They are used in the manufacturing of military helmets. They are also used in the manufacturing of tires, brake pads and lining for clutch, right, and they are used in the manufacturing of ropes, cables, right, and fire resistance clothing, right. So these are all the applications of this Kevlar fiber. The next polymer is polyester. Okay, now let us discuss the synthesis, properties and industrial applications of polyester. Okay, industrial applications of polyester, right? So as we all know that polyester falls under fibers, right? So it is a manufactured fiber in which the fiber forming substance is any long chain synthetic polymer consisting of at least 85% by weight of a dihydric alcohol, right, and terephthalic acid, right? The most widely used polyester fiber, is formed by the linear polymer, so that is polyethylene terephthalate, right? Polyethylene terephthalate. So polyethylene terephthalate. So this itself, in short, it is called as PET, right? It is the most commonly used polyester, right? Polyethylene terephthalate, and it is in short it is called as PET, right? So it's high strength, high modulus, low shrinkage capacity, right, and light fastness, chemical resistance, heat set stability, all these properties account for the versatility of polyethylene terephthalate, right? Polyethylene terephthalate. So if you come to the synthesis of this polyethylene terephthalate is a condensation polymer, and it is obtained by the condensation polymerization of either terephthalic acid or dimethyl terephthalate with ethylene glycol, right? With ethylene glycol. So that's why we can start with the synthesis of this polyethylene terephthalate or PET or polyester. So if you look at the synthesis, so we need to start with terephthalic acid. So coming to the formula of terephthalic acid, so here I'll write, so COOH. So two COOH groups will be present at the para positions of the benzene ring, and this, if we treat with methanol or methyl alcohol, that is CH3OH, so it undergo condensation reaction with the liberation of water molecules, so that we are going to get the next product, and that will be COOCH3 COOCH3. So this is dimethyl terephthalate. So this is called as dimethyl terephthalate, right? So dimethyl terephthalate, this we are going to get. So now this dimethyl terephthalate undergo reaction with ethylene glycol, so that we are going to get diethylene glycol terephthalate, right? So this will react with, so here only can I write, so or else, yes, I will write it here. So same dimethyl terephthalate, so now it will undergo a reaction with COOCH3 CH2OH and CH2OH. So this is called as ethylene glycol. Ethylene glycol, it is any dihydric alcohol, right? If we treat this with dimethyl terephthalate with ethylene glycol, so it is going to give diethylene glycol terephthalate, and it can be written like this: COOCH2CH2OH, and similarly COOCH2CH2OH. So now this diethylene, right, diethylene glycol terephthalate, okay, diethylene glycol terephthalate undergo condensation polymerization with the elimination of simple low molecular compounds such as alcohol. We are going to get a long chain polyester fiber, and that is called as PET, polyethylene terephthalate, and its structure can be written like this: it is dot O, right? We are starting from that, so H will go there, and then CH2 two times, here CH2 two times, and then you can call it as OCO, and then we are getting this benzene ring, right? And then COO, CH2 twice, and then OCO, and then once again one more benzene ring will come, and similarly COO, CH2 twice, O dot dot dot. So this is the polymer polyester. It is also called as polyethylene terephthalate. In short, we can call this as PET or polyester, right? So this is all the synthesis. This is terephthalic acid, actually terephthalic acid. This is methyl alcohol. Okay, so these two undergo condensation reaction in the beginning, though we will get a dimethyl terephthalate. This will undergo reaction with ethylene glycol, thereby we will get diethylene glycol terephthalate, and this undergo polymerization, condensation polymerization, we are going to get a product, and that is called as polyester, right? So coming to the properties, so if you look at the properties, right, in the name itself it is there. So this polyester polymer, it is resistant to stretching and shrinkage or shrinking, right? It is resistant to stretching and shrinking. Properties, if you are going to write the properties of polyester, it is resistant to stretching. Okay, it is resistant to stretching and shrinking. Resistant to stretching and shrinking, right? And it is resistant to most of the chemicals. That is very, very important. And it is, easily, it can be easily washed. Resistance to most of the chemicals, right? So it can be easily washed, and quick drying is going to take place, and it exhibit crisp and resilient property, wrinkle resistant, abrasion resistant, mildew resistant. All these are the properties of this polyester fiber, right? So with these properties, if you can go and see the applications, right, if you can go and see the applications, this polyester polymer is used in the manufacturing of apparels, right? It is used in the manufacturing of apparels. Apparels means every form of clothing, in the manufacturing of every form of clothing, right? That is called as apparels, right? And then it is used in the every form of apparels, right? So then it is used for house utensils, right, or home furnishings. It can be used for home furnishings. So here home furnishings means this polyester can be utilized for for the synthesis of making of this one, what is this, curtains, right, carpets, and then window coverings, right, wall coverings, or sheets, pillowcases, right, upholstery, etc. And if you look at the other applications or other uses, it can be used in the manufacturing of hoses and fillers for the filler fibers, as a filler fiber for the different pillows and different furnitures. It can be used in the manufacturing of power belting and net, in the manufacturing of ropes, tire cord, right, etc. So in all these places, this polyester can be utilized, right? So because of their high strength, high modulus, low shrinkage, and they are resistant to stretching, and they are resistant to almost all the chemicals, so it plays very, very important role in the polymer field, right?